know everybody's opened the door, like especially in the summertime, you know, you go somewhere to a house and they'll open the door and you feel that gush of cold air come out. Well, the reason is because the house is leaking on the other side, okay, and it's just literally a windstorm coming through the house and it's blowing it out. When the house is tight inside, there's no back pressure, so they open the door and basically the cool will stay inside. And then you don't have near as much exchange, and it's one of the ways it saves energy.
Just kind of a footnote on that. How many of you here think that you can make a house too tight? Have you heard that? No?
And they have to put like, to clean the air, filter the air somehow, because no new air is entering the house.
There's I guess this old saying is, you can't make a house too tight. And I'll tell you, I don't want to get into these stories, but I got to tell you this one story. I measured a house some years ago, and this couple had put their heart and soul into this house, and they did a beautiful job of. It was what's called doggone, my mind went blank. A SIPS house, structured insulated panel system, SIPS house, and so the walls, you know, inherently were very tight and a really good wall system. Beautiful shell. And then when they went to put the mechanical systems in, the guy said, hey, the house has to breathe. This is going to be too tight. So they cut holes up in the top so that their house would breathe. Now, that's the worst thing, and the house failed. They put their heart and soul into it, did everything, put a geothermal heat pump in it, and the house failed. And they wanted to cry. And I wanted to cry for them because they had put so much into that house. And then the guy, because they listened to one guy give them the wrong information, and what he said was, houses have to breathe, this one's too tight, and so they made some deliberate penetrations in the top of that house. Now, there's two types of holes. There's a designed hole and an undesigned hole. We like designed holes, we don't like undesigned holes. And in order for us to control what goes on beyond these walls, which are what we're calling, these walls do two things. They're the thermal barrier, but they're also the air barrier. And so that defines your conditioned space beyond these pink walls here, right? And so we want to be able to control what goes in there. If you have a house that's leaky, and so that means air infiltration, not ventilation, two different things again, ventilation and infiltration, very different things. So if you've got infiltration, by definition, you don't control that. So air just comes in willy-nilly, you know, and it comes in depending on different things. You know, vapor pressures, something called stack effect, wind pressures, all those things will impact that. But I promise you it happens all the time because I measure them all the time, and they leak. So what comes in with air is dirt and moisture and heat or cold. We don't want any of those things. So in my opinion, and this comes from years of doing this stuff, you can't make a house too tight. So you make it as tight as you can possibly make it, as tight as a plastic bag if you can, and then you get an atta-girl if you can do that. But if you can't do that, do your best. Then measure the airflow. So what's happening right now, there's no enforcement. There are standards out there for what's called air change per hour. So these things are very important, and they're not being attended to right now. The only people that test these things are people like myself or the programs, where we'll come in and we'll test and see how much air flows in this house. If this house was extremely tight and it was perfectly sealed, we'd have no airflow. I've yet to measure one of those, but there's standards called ASHRAE 62.2 is the current standard for ventilation for the low-rise stuff, and you use that standard to know whether or not you've got adequate ventilation, whether or not you got the right amount of air coming into that thing, and so that's very important, and that's why when you see Dave and Danny talk about, you know, well, we put this caulk here, we did this or that. Everything they do comes at a cost. And so you've got to be able to recover that cost. And we know, because we measure it, that when you do that, it'll give you a return on your investment. So I can take a leaky house and a mirror image non-leaky house, and using the software that we have available, we can calculate that. And we can see that Yeah, it does perform a lot better, and yeah, you do get $150 back a month savings in utility bills. So this is real stuff, and that's why I just wanted to point it out.